So a lot of stuff going on today. Oh, I thought they had that taken care of. A lot of stuff going on today, and we will be reviewing the formulas and stuff we're going to start with are things that you should have gotten yesterday in your entrance ticket. So hopefully you've got all these formulas down, but we're just going to go over them one more time. And there are a couple extras here. So you're going to want, if you missed anything, you're going to want to copy it down. But again, these are things you're going to need to know. Slope formula, which is what? Okay. Now, I've noticed several people, and I commented on it when I saw it usually, but not always, so if I missed it, a lot of people are writing it this way, okay, with superscript instead of subscript numbers. Superscript numbers, numbers up above like that, are representing exponents, not like second number, first number. So technically this is incorrect. This is y squared minus y to the first. It's not y2 minus y1. You really need to be writing it with the subscripts, not the superscripts. So be careful about that, please. Distance formula. Square root of squared plus midpoint formula. It's a point, so 2 plus y2 over 2. The most common mistake people make is they turn this into a minus, or they do, or they try to square it. Nothing gets squared there in the midpoint. That midpoint is the easiest one. It's just an average. Add, divide by 2. And of course, Pythagorean theorem, plus b squared equals. That's pretty straightforward. For our angles in circles, you have the central angle, which is at the center, and the measure of the angle equals the measure of the arc. In scribe, the measure of the angle is 1/2 the measure of the arc. Interior, the measure of the angle is 1/2 the sum of the arcs. And exterior, the measure of the angle is 1/2 the difference of the arcs. And then for the exterior arc, one has to be the larger arc. Okay? It must be the larger arc. What's the formula for circumference of a circle? Diameter times pi. And the arc length formula, this is the other one we were using a lot. Theta over 360 equals arc length over circumference. Again, in case you're wondering what goes where, it's small part over the whole thing for angles, small part over the whole thing for circumference. The arc length is a part of the circumference. The whole circumference, pi times diameter, is the whole circumference, or diameter times pi. For these problems, I am going to go ahead for the most part and say go ahead and approximate those if you want to. You can put them in your calculator and decimalize those if you want. You can have the fractions if you want. I think it's a better answer, but if you want to decimalize it, go ahead. Because I saw a lot more mistakes just reducing the fractions than anything else. If people got it set up correctly, but then couldn't get the fraction solved out of it. So if you need to decimalize it, go ahead. Again, if you're going to do that, we have to solve this by cross-multiplying and then solving for whatever's unknown. This arc length is not always the unknown. It is in the easier problems tending to be the unknown, but sometimes I don't know the radius of the circle, in which case I need to solve for circumference and then backwards do that for diameter and then for pi. Divide by pi and then divide again by 2 to find the radius. Sometimes we solve for the angle. There was one in the homework today where we actually had to solve for the angle. By the way, the answer for that one in back was wrong because the problem was altered on the review sheet. I don't remember what number it was, but 20-something. 22, yeah. The answer was definitely incorrect in back because you could see the problem was altered from what the computer generated. That's the computer-generated answer. That's not the actual answer because we altered the problem. I think it winds up being like 189 or something like that. 189 point something. Okay? Other formulas we're going to have to know. This is for the segment lengths. And this is always the same. This formula is the same for both situations because it's really the same problem. We always start every segment at the point of intersection. PA times PC equals PB times PD. At no point do I use just a chord of the circle. So here the intersection is on the inside. That's fine. If two along the same line are multiplied. Here the intersection on the outside, PA times PC, not AC. I don't use just the chord. I have to do the whole thing. Some people remember outside part times whole thing, outside part times whole thing. If that helps you remember it, whatever. But again, the formula always is set up so we start at the point of intersection, not ever just a chord with 2 points on the circle and no point of intersection. So those are the way those problems set up. Now what I've done is I've just created a couple problems of review for us on the smartboard itself for just automatic review ones, and then everything else is just going to come based on your questions from the review sheet. There is an additional assignment tonight. Let's get that up here right away so no one gets confused about that. Again, it's more review problems because the more review, the better chance we're going to have. Page 915, 31 through 53 odd. And page 917, 29 through 32. These odd ones, the answer should be in the book, so you should be able to catch that. These are part of the chapter reviews that are at the back of our book. So, by the way, just a reminder, they do make such a thing called an assignment notebook and paper, so you don't have to just write the equations on your hand. So 915, 31 through 53 odd. 917, 29 through 32 is what we need to be working on tonight. Again, that's just additional preparation for this test. And this is a test tomorrow, not a quiz, so remember that. Very important, score-wise. All right, let's take a look at those couple questions. I actually have two problems in each drawing. One for segments, one for angles and arcs. So, let's start with this one. Let's start with the circle on the left with the exterior angle here. Let's do the arcs first. Where's the vertex of this angle? Outside, so the measure of the angle is 1/2 the difference of the arcs. The arcs, the larger arc is 80. I'm sorry, I don't need arc 80. It's just 80. Minus what? 20. So that's 1/2 of 60, which is 30. So my angle here is 30 degrees. Next, we have to find the segment length, the unknown segment length. So how am I going to set this up? Vertex is outside the circle, so we start here. PA is, we'll call 6. What am I going to multiply that by? 6 times what? 6 plus x, not just x, not 6 times x, but 6 plus x. I'm going to add those together. Equals 7 times what? 18. I'm going to add those together again. 18. So that's 6 times 6 plus x, that's 36 plus 6x equals 7 times 18 is 70, and 56, 126. We'll subtract the 36. I get 6x equals 90. Divide by 6, so x is 15. And there we are. For this one, again, we'll start with the angle situation here. Now, x should be my angle, so let me move it up there a little closer. There we go. X is my angle. What's the relationship between what type of angle do we have here? Where's the point of intersection? Inside, but not center, right? Not inscribed. Inscribed is vertex on the circle. Interior. Okay? So the measure of the angle is 1/2 the sum of the arcs. So that gives me 110, which is 55. How about for the segments? Someone set that up for me. I'll start with the point of intersection here at 4, or at there, and it'll go up this way. So 4 times what? Equals 8 times 5, which is 40. So 4y equals 40. So y clearly is going to be 10. So setting up and solving problems like that, big part of the test. Oh, you know what equation I didn't write down in the equations we need to know? I did not write, and we should have on here, equation of a circle. What is the equation of a circle? Squared equals r squared. Everything's squared. It's like a squared plus b squared equals c squared. Everything's squared. Because it is Pythagorean theorem. HK represents the center of the circle. R is the radius. Remember that's r squared in the formula. R is the actual radius. It's the square root of that. All right. Those are all the prepared problems I had. Which problems would you like to go over? 15. You know what? I need to have a copy. I need to have a copy of the review sheet to do that, which I happen to have right here. Okay, 15. We had something like that. We had 137, 103, and x is up here. Okay, a couple different ways I could look at this. But the easiest is it's an interior angle, so the measure of the angle is 1/2 the sum of the arcs. Multiplying both sides by 2, that gives me 206. Plus x, subtract the 137. 70, 69 equals x. Okay. Next one. 22. Okay. Yep. Like I said, the answering back for number 22 was incorrect. But that's okay. It's still a good problem. Not drawn to scale here, really, unfortunately. Well, let's just kind of draw like that. The radius is 13 meters. This arc here is 45 meters. It says a measure of arc ABC, not the arc length, but the actual arc measure. Okay? So it wants the arc measure, not the arc length. We know the arc length is 45. We want the arc angle. So again, we go back to our formula. Angle over 360 is arc length over circumference. The angle is what's unknown here, so the arc length is given at 45. The circumference is 26 pi. So we cross multiply. 360 times 45 equals 26 pi times theta. Putting that in my calculator, I get 360 times 45. Hold on. 16,200, yep. Now I have to divide by 26 pi. That'll give me theta. But I have to be careful here. I have to take 1600 divided by parentheses 26 pi. If I do it by 26 times pi, it's going to divide by 26 and then multiply by 3.14, which won't make sense. And I get theta is 198.33. Here's my arc angle. But again, like I said, when I put that in my calculator, if I do 16,200 divided by 26 times pi, it's going to do order of operations as left to right with multiplication and division. So if you just put it in like that in your calculator, you get 16,200 divided by 26 times pi. The pi winds up on the wrong side of the fraction. That's why it's important when you're setting this up in your calculator that you put the parentheses around the product. Your calculator has parentheses, use them. Or you could calculate the 26 pi first. 26 pi is 81.68. And you could have taken 16,200 divided by 81.68. All right? But be careful with that. Next question, yes. 21. Yes. Setup isn't so bad. Solving it takes a little more work. But again, this is one of those problems that, on the test, you could very easily get some points just for having the right setup. It's 6, x minus 8, x minus 3. So how am I going to set it up? Start at my point of intersection. Which segment do you want to start with? 6 times 6 equals, okay. Is that just going to give me x squared plus 24? No, I have to FOIL that out, don't I? Okay. So 36 equals x squared minus 11x plus 24. What are we going to do both sides? Subtract the 36. X squared minus 11x minus 12 equals 0. So my magic numbers, okay, negative 12 and 11, or negative 12 and 1. When I add them, I get negative 11. When I multiply them, I get negative 12. So that means to get a factor to x minus 12, x plus 1 equals 0. So what values of x do I get to put in there? 12 and negative 1. And negative 1 does not work, so 12 is my solution. I could check that pretty easily. 12 minus 3 is 9. 12 minus 8 is 1. Excuse me. Oh, 12 minus 8 is 4. Excuse me. 9 and 4, 36. Sorry. I got that 9 in my head, and I did 9 minus 8 instead of 12 minus 8. Yep, 36 equals 36. It works. Next question. Yes. 5 and 6. 5 is just a Pythagorean theorem. If you recall, the idea here is that if I have a radius and a tangent, then the intersection between the radius and the tangent must be a right angle. So what they're saying here is this actually a tangent line, or is this a right angle? We had 12, 16, and 8. I need to know, how long is this segment just from the center to the edge here? 12. So the whole side is 20. Last time we put this on a quiz, a lot of people did 12 squared plus 8 squared equals 16 squared. No, that didn't work. We're done. You got to build it up. You don't have everything you need right away sometimes. So 12 squared plus 16 squared compared to 20 squared. It's 144 plus 256 is 400 equals 400. Yes, that is a right angle, so yes, that is a tangent line. Okay? Anything else? Like I've said, the quiz that you're going to see, the test you're going to see tomorrow is very, very similar to this worksheet. So if there's something you didn't get, now's the time to ask. Because it could save you a lot of grief tomorrow when you actually see the test. $13, yes. By the way, for number 12, what has to be true about those angles? Is that angle going to be 84? They have to be supplementary. Got two tangent lines. This arc is 135, that's x. Well, again, I don't have enough information yet to find x, but I could, since 135 just goes from here to here, what's the rest of the circle going to be? 225. Aha, now I've got it. 225 minus 135, half of that is x. So that's negative 90. I'm sorry, positive 90. Why would it be negative? Okay, I did it backwards. So positive 90, which is going to be 45 degrees. Is that angle? Okay. Other questions? Yes? 28. Provide the equation of a circle. Oh, it gave you a center and a point on the circle. Yes. Well, since it gave us the center is at 12, 9. So that tells me it's x minus 12 squared plus y minus 9 squared. The thing is, I have to find what r is going to be. The point on the circle is 11, 13. So if I can find that distance from the center to that point, that's the radius of the circle, right? So distance formula. X minus x, 12 minus 11 squared. 9 minus 13 squared. That's 1 squared plus negative 4 squared. 1 plus 16 is the square root of 17. That's my radius. So my radius squared would be 17. And there's the equation of that circle. Pardon? Counting isn't going to work so good here. Well, I suppose you could set up Pythagorean theorem and do it that way. But distance formula, know how to use it. All right, other questions? All right, well, you do have the remainder of the period to work then. Please actually do that. Work the remainder of the period. And good luck. I'll be in bright and early tomorrow morning for people who need additional help. Tomorrow's test and our last day before break. Woohoo! Somehow I got extra icons up here. I gotta hide this some of these. For retake? Yes.
Okay.
All right.
Oh my God, I just love this.